Hello, everybody. Welcome to our DevOps Demo Day. So we'll kick it off with some introductions. We'll be talking about testing your cloud applications on GitHub Actions with using Kind. So let's get everybody on the screen so we can go through some introductions. All right, I'll kick it off really quick. So hey, everybody, I'm Sarah Khalife. I'm a solutions engineer here at GitHub. I work on a lot of the enterprise accounts. Previously, before I joined GitHub, I was a senior software engineer there, working on some of their cloud applications using Kubernetes and a couple other things. I'm originally from Cyprus and Lebanon. Currently live in San Francisco. You'll see some cool pictures here from a couple of my favorite spots to visit. And if I were a tour guide and you're visiting San Francisco, I would actually take you up Route 1 to see some of the beautiful coastline there, and then visit the Mist Trail at Yosemite Park, as well as the famous Golden Gate Bridge, but specifically from the Battery Spencer side of things. So I'll pass it over to Grant.
Hi, everyone. Hi, I'm Grant. I'm a software engineer at a company called Pure Storage, and I work on a product called Portworx. Portworx is a cloud-native storage platform, and specifically, I'm the tech lead for the Portworx CSI driver. I also am a contributor to Kubernetes, specifically the Kubernetes CSI project and Kubernetes SIG storage as well. But I'm not coding or in the office. You can find me climbing mountains, rock, ice, and snow. So those are some pictures of me out there.
Where's that one picture? Where's this picture taken where you're on top of this tiny, huge mountain?
Oh, that's in the French Alps. And then the one on the right is just in Tahoe, nearby, California.
That's awesome.
And every time I see that photo, it's incredible. I love it.
It's a crazy photo.
So nice to see everyone logging in here and joining us today. My name's Adam Barlow. I'll be the moderator, so I won't be speaking as much as my other two colleagues that are on the line. But I love to travel. I've been to close to 30 countries. I have also been skiing since I was 4 years old. So if I can travel someplace and ski, I'm a happy camper. And during this like COVID time, I picked up becoming a chef. So I'm this is like one of my favorite dishes that I've ever made is a homemade pasta. So it only took 7 ingredients and it was superb.
That sounds delicious. Mm-hmm. And where did you take these skiing pictures, Adam?
So the two on the left, the selfie and the one with my wife, that's in Tahoe. And that one on the right, that's actually in Whistler. So Whistler is probably one of my favorite places to ski.
That's awesome. Everybody in the chat, let us know where you're from, or what are some of your favorite places to visit when you're in the Bay or wherever you're from. All right, so what we'll be doing, we'll be covering some topics that we actually have a demo that we did, a similar demo that we did for KubeCon. So within this demo, we'll be presenting and talking about how you can test your cloud applications across using GitHub Actions and Kind to have a homogeneous testing environment. Overall, this was somewhat presented at KubeCon as well, and we're taking that and making more specific to how you can leverage the specific GitHub Actions tools that are available to you today. If you participate at KubeCon, let us know. If you have any questions, feel free to post in the chat, and we'll answer them live if we can. All right, and I'll be kicking it off. So first, we'll do a quick overview, talk about Kind, testing automation, and takeaways. We'll also be doing a live demo, so stay tuned for some of the live action that will be happening there. As you see throughout all these presentations, KubeCon, we were supposed to go to KubeCon Europe, but it was canceled, or it was postponed and made virtual because, the pandemic that's going on today. So you'll see a lot of pictures throughout of Amsterdam, just so we can feel like we're hanging out there while we're talking through all the cool, fun Kubernetes capabilities that we have today. Awesome. So we want to be able to collaborate successfully in both internal open source projects. That was our main motivation. Both Grant and I worked on a lot of Kubernetes projects, and we'll talk a little bit about that later on today as well. And we noticed that Kubernetes does a really good job in maintaining a lot of things very consistently. But one thing that we've seen is that that's how it's successful. So how do we improve that? How do we maintain that? So what are some challenges that a lot of open source projects and internal projects have been seeing? Overall collaboration needs to be more transparent, consistent, and rigorous. We need to test our Kubernetes applications consistently, and it varies per developer environment because everybody has a setup, a different dev setup locally. And then it takes up time and resources to constantly spin up Kubernetes clusters. You don't want to spin up a full-blown Kubernetes cluster if you're doing some quick end-to-end testing. As I mentioned earlier, we'll cover some topics. We'll set some steps to create and automate our testing environment, use Kind to automatically run our end-to-end tests across a common environment, and then we'll be automating the creation of these tests per pull request and run the test suite before even merging. Yeah. So I'll pass it back to Grant to talk a little bit about Kind.
Yeah, so just a little bit about Kind. So Kind is basically Kubernetes and Docker. Kubernetes, since we haven't really covered it too much yet, it's a container orchestrator. Specifically, you can run Docker containers or any kind of containers that you have. So it's pretty easy to set up Kind. Kind actually just requires Docker to be running on your system. And all you need to do is on a Mac, you can type brew install Kind, or Linux if you have brew installed. And then you could just do Kind create cluster. And that'll bring up a small Kubernetes cluster on your local machine. So yeah, if you can click on the kind.sigs.k@s, this is the Kind website. So Kind is specifically a SIG within it, Kubernetes, within the Kubernetes project. So what that means is it's a special interest group. So if you're interested in getting involved with Kubernetes, you can join the Kubernetes Slack and join the Kind channel. You can go ahead and check it over there. So here's the GitHub page for Kind as well. So if you are interested in contributing to Kind, here's where you could go to see it. So yeah, we'll send a link if anyone wants to see that. And yeah, so that's pretty much Kind in a nutshell. This is the thing we'll be using to spin up our Kubernetes clusters for our testing in this demo today. So you may have heard of a couple other tools similar to Kind. There's K3s, Minikube. Those are just a couple others that are similar in usage. So what makes Kind different is that it just requires Docker running on your system, and the overhead is very small. You just need Docker. So it's really easy to run in things like Jenkins or in GitHub Actions or anything that you want to run your CI/CD in. So it's a great tool to basically spin up an easy Kubernetes cluster. Minikube is a single node Kubernetes, also low barrier to entry, and then K3s is a minimal cut down version of Kubernetes that has some features removed to keep the footprint really small. So we have a link to this blog post right here. So this is a blog post that kind of went over a comparison of all three, if you are interested in seeing more of this.
For those on the chat, if you have used any of these tools, what are some pros and cons that you've seen? If you haven't used any of these tools, what are you interested in seeing for another demo, possibly? Awesome. So let's talk about a couple of our goals. So we want to run our end-to-end validation testing. We want to set up a pre-configured environment, block any merges to production if those tests aren't passing, and automate everything. Nothing should be manual because it allows you to keep it consistent. We want it to be a little transparent, or we want it to be very transparent and maintain that rigorous testing. So we're doing it per pull request. And whenever we are running our tests, we're actually hoping to block the merge because we don't want to introduce any new bugs into our production environment. At the end of the day, we want to increase the frequency and maintain everything very repeatable. To use Kind in actions, we actually found a GitHub action that's already provided by the open source community. So if you think of actions, if you think of actions as an open source tool, think of each action itself as an open source automation tool that you can use. In this case, I was able to find an open source action that does kind cluster creation. So I didn't have to do all the pre-work to create a new kind cluster action because it's already out there. And you'll be seeing this in the actual workflow while we're covering it later on. So let's take a walk by the river here. This is a beautiful river that is in Amsterdam that we wanted to go visit while we were there, but it was something that we could not do. So I decided to build our workflow pipeline across this. So our kitty cat dev will be introducing code change and creating a pull request. In this overview, in this pull request, she'll be introducing new changes. So we need to run a build and publish Docker image just to make sure that all those changes are being leveraged. And then to really test the changes that KittyCat Dev made, we want to jump into a kind cluster creation and run a Kubernetes end-to-end testing. And what we also really are planning to do is testing across all the Kubernetes, or the latest Kubernetes environments that we have available. So today we'll be testing against 1.17, 1.18, and 1.19. And once all the tests pass, we'll be merging the pull requests.
Cool. So if we want to run some tests, we need something to test against. So we'll be testing against the product that my company builds called Portworx. So Portworx is a storage platform for Kubernetes. Specifically, it offers things like storage, disaster recovery, migration, autopilot, and security. So just a lot of automation and DevOps and intelligence around storage within the Kubernetes ecosystem. We also have a backup product called PX Backup. So we'll specifically be testing something called the Portworx CSI driver, which I'll talk about in the next slide. So yeah, I mentioned Portworx security. This is the main feature that we are going to be testing. This feature prevents unauthenticated users from accessing our platform. So pretty straightforward at a high level. And then we'll be using something called the Portworx CSI driver to do that testing. So CSI stands for the Container Storage Interface, and is a project maintained by a lot of folks that work on different container orchestrators. So DCOS, Kubernetes, and a couple other container orchestrators are all working together to make this common storage interface. And Kubernetes has its own implementation, and that's the team that I work on in the open source side of things. So yeah, so we're going to be testing the Portworx CSI driver, and we're going to be using something called Open Storage. Open Storage is the open source control plane for Portworx. It's also where the CSI driver sits. So that is the code that I'm going to be demoing today, fixing it. So yeah, this is the E2E test that we're going to be running. So let's go ahead step by step. So first, we're going to create the kind cluster. Then you can click to the next one. So yeah, then we're going to deploy the CSI driver. And so the pod is going to come up in the kube system namespace. Then we're going to create the token secret. And then next, what we're going to do is create what's called a storage class. So a storage class is basically a template for a volume. Basically tells the container, it tells the storage driver what, basically how to create the volume and what kind of properties you want for this volume. So yeah, then we're going to create the persistent volume. And then next, we're going to create a pod that uses that volume. So for this demo, what we're going to do today is use MySQL. And we're going to have a volume we're going to have a Portworx volume that's provisioned by the Portworx CSI driver, and it's going to be used by the MySQL pod. So I know that's a lot of words to take in. You're not familiar with Kubernetes, but in a nutshell, what that means is that we're going to be running an application. That application needs storage. It needs persistent storage because there's data that we want to hold. So we're going to use what's called a persistent volume in Kubernetes to do that.
Awesome. So let's jump into the demo.
Yeah, so I'll share my screen, and what we can do is go into the live demo. So what we have here is VS Code. So we actually have the open storage code base open right now. So let me actually pull up open storage real quick, and I'll just show you what I mean by that. So here is the main open storage repo. This is the open source control plane for Portworx. It's just a Go repo with a lot of different APIs, a lot of Go code for authentication, migration, backup, that kind of stuff. So if you're interested in how that kind of works, you can check out the GitHub repo at github.com/libopen-storage/open storage. But specifically, we're going to be using a fork for this demo because we didn't want to mess with anything on the main repo because we want it to work quickly. So if you are interested in checking out a lot of the demo code that we've been showing today, you can actually go to github.com/escalife/open storage. And yeah, so there's some helpful links there as well for you to check out that we've talked about today. And yeah, so now that we've kind of gone over the repo that we're going to be contributing to, let's go ahead and get into the code. So I have some code here. It looks like the screen is big enough. Let me know if you need me to make it bigger. We have some code here that I've written last night. Really tired when I was developing, so let's see if everything is good. So we're just doing, actually, let's take a look at the branch name. The branch name is just go lint fixes. So what my task here today is basically, I have a bunch of like linter fixes that I need to do just to clean up PR to kind of clean up the code base and make it look a little nicer. So go ahead and check out what changes I've made in the diff. So pretty straightforward changes, just some renaming, more renaming, an import, fixing a log line. And cool, it looks like we are good. Let's go ahead and commit all of these changes. We're just going to do git commit -s, sign the commit, and we're just going to do fix some lint issues. Very innocent pull request, nothing wrong with it. So let's go ahead and create this PR. So I actually started using the GitHub CLI this past week. So it's actually pretty easy to use. If you can just download it, and I believe there's a brew command to install it, but we can include some docs about that in the end. But let's just check out what the GitHub CLI can do. GitHub CLI can do a bunch of different things. You can list your gists, issues, PRs, releases, repos, but specifically what we want to do is do git PR create. So now that I've made my branch, I've committed my changes in the branch, I can go ahead and create this pull request. So it's going to ask where we want to push this branch to. We're working on Sarah's fork, so what we're going to want to do is push to that fork. And the title, you could just keep it the same as the commit for now. And nothing really in the body is necessary for now. So we go ahead and submit this PR. So CLI is doing now is sending a pull request to our fork. And so it's sent the fork and it sends the PR. So what we can do is pull this PR up in the window. And cool. So my PR is submitted to our open storage fork. We have some very straightforward changes, like I mentioned, just a lot of Go lint fixes, pretty straightforward stuff. Cool. So now we have some tests running. And yeah, Sarah, did you want to go into what exactly is happening now that I've opened a pull request to our repository?
Yeah, so what I'll do, I'm actually going to go over the workflow. So if we can switch back to my screen, here we have our GitHub repository. In order to build a GitHub action, if you are familiar with GitHub Actions, let us know in the chat and we'll cover some even more in-depth topics. But if you aren't familiar with GitHub Actions, you can actually go to the Actions tab. And then I actually have a couple of jobs running. But what you would normally do, you can just click on New Workflow. When you click on New Workflow, it automatically detects that the repository is using Go. So it says, hey, do you want to just build your Go pipeline and set up this workflow? If we're doing a little more CD, we can also deploy to all of the different cloud providers. But we have a lot more CI integration flows, continuous integration flows that really allow you to build more end-to-end testing. But what we've done, because we wanted to use kind, these are story workflows developed by our ecosystem. So you can take these and customize them, or you can take them and use them as is. You can easily deploy to Azure, building a Docker image and everything. But today we wanted to use the kind action. So we actually built a end-to-end kind YAML here. Within the actions YAML, you'll see that we have a trigger. It's being triggered on, and let me zoom in a little so people can see much better. You can trigger on pull requests. Previously, we actually had this trigger on pull request and on every push, and we weren't specifying the branch. But in reality, nobody needs to run end-to-end testing every single push. It makes unnecessary work. I think overall it uses up resources that you might otherwise just only need on pull requests. So we actually cleaned it up a little and made it only on pull requests specifically to our production branch. Because end-to-end testing, like I said, we don't want to test that every single push, but unit testing makes more sense. If we wanted to test every single push, a unit test that we have for open source that could work. But for end-to-end, it only makes sense to do the end-to-end integration testing when we're pushing to our production branch or our active development branch. So we have a couple of environments set up here. So if you notice, we're actually using a ghcr.io. So if you're unfamiliar with that, GitHub Container Registry was recently announced in beta. So under GitHub packages, so you have Maven, you have NuGet, you have a couple other type of package registries. We now can do container registry as well. We could do that before, but now it's more focused on building out I would say end-to-end, where it's not just Docker images. It could be any type of OCI type container. So with that, we also, if you notice, we're setting the run ID as the version of this image. Well, in this case, we wanted to keep it simplified, and we didn't want any of the images to collide in case we're running concurrent jobs. So every time when you run a spun up, the run ID is used. So this allows us to make sure that for this specific pull request, this is the image that is being built. If somebody introduces a new code change, then it'll be a different run. But if you're just restarting this workflow, if you're just doing a rerun all workflows for the specific one, then you wouldn't even have to change the run ID. Again, this is an environment variable, so it automatically does that for you. What we also have here is we have jobs. So you can have a couple of concurrent jobs. You can have, so jobs are concurrent and asynchronous, and then you have steps that are very concurrent and in a specific order. In this case, I have a build job and a test job. In this build job, I'm actually building out the Docker image and then pushing it to our GitHub Container Registry. We're doing a simple build Docker image. We're doing a make Docker build. So we have a make file and a Docker file that we're compiling. And then we have our Docker login. Very common to, if you're familiar with Docker, overall, it's the same way you can log into GitHub Container Registry. The really nice thing about this is that it uses the GitHub's user management. So you don't have to go create a new set of credentials. You can use your existing credentials today. If you are an enterprise user, this comes with, I think, 50 gigs of packages available. Even if you're an open source contributor, there are packages available for you today. So all of this is available for anybody to test it out. We're also doing an image push here. So simple overview of this. We are tagging the image with the specific test ID image name that we provided at the environment variable here. And then we are doing a Docker push image. So now that image will be stored in GitHub Container Registry. Here we have our test job. So this is, usually jobs can run concurrently, but in this case, I really wanted these test jobs to wait for the build job to pass because it doesn't make sense to spin up tests without having the Docker image pushed. So what we have here is also a matrix build. So you can see we have labeled here K8's version 1.17, 1.18, and 1.19. This allows us to spin up 3 concurrent jobs to run our tests. So with that, we were able to use this variable and put it in our kind action that we were leveraging from the open source community and spin up this job 3 different times with all Kubernetes versions. If you want to see how this action runs, you can, obviously, it's fairly simple here. You can see I'm setting up kind and spinning up the cluster. So it's using we're naming it the open storage cluster. It's using our YAML configuration here, and we're spinning up the Kubernetes versions here. And then we're using version 8.1 for the kind version. If you want to see specifically what this kind action does, you can actually take this URL and you can put it at the end of github.com and pull it up. So all of these actions are open source. You don't have to reinvent the wheel. You can just work on something that is actually differentiating and leverage existing tools. So in this action, if you look through all the README section here, it gives you specifics on how you can set it up, what you can configure, what tools, what variables you might need, and what are some of the best practices. And you can do that with almost any open source action. If you wanted to find more actions, you can actually go to the marketplace and talk pull any actions from there. So with that, well, in this case, we're starting. So we had our kind job being spun up, where it spins up the full kind cluster, which is Kubernetes and Docker. And then we start our open storage configuration, and then we do an environment check here, and then run our end-to-end tests. So overall, a simple workflow, and I will let Grant talk to it in a second. And I just wanted to go back to the pull request and see what's happening. Interesting. So we can see the job failed, Grant. Let's go check where it failed. So we can see the build job pass. So it's not in the build. So I guess it's when it's spinning up the Kubernetes cluster. So let's see here. If you look through, all the logs are available for each of these jobs that were spun up. So in this case, I'm looking at the one that was spun up for test for version of Kubernetes 1.17. And if I zoom in a little here, we can see that there's an unauthenticated. Interesting. So normally I could just tell Grant, hey, you broke this. But in general, remote collaboration isn't as easy as that. So what you can do is actually copy the link to the actual error. So all of the logs are linkable, and that's I'm telling you, it's like a super convenient feature, because when things break, you just want to make a comment and say, hey, this doesn't look right. What's happening? So I'm going to go add my review. I'm going to comment and tell Grant, please look at this error because I don't understand why it's failing. And then I can just comment. So in a remote world, Grant will get a notification and see that I commented, hey, the error failed, and then he can click on this URL. So now that the error failed, I'll pass it back to Grant so he can actually fix this issue.
Cool. Yeah. So looks like Sarah commented on my pull request. I can start sharing, and I'll go ahead and take a look. So yeah, it looks like Sarah just commented. Let's see what she said. Also looks like my tests have been failing. So let's go ahead and see what Sarah has found. Okay, so looks like the Portworx CSI driver is not able to authenticate with the backend for Portworx. It looks like Portworx is denying the request. So good news is Portworx security is working. It's not letting people in, but bad news is users can't create their PVCs in this case. So let's go ahead and take a look at my code again. Let's see what I have here. Just some golint fixes, more comment fix. Looks like we have a bug that I introduced as part of this PR. So it looks like I added an equal sign by accident. I must have just typed this by accident, my editor or something. So let's go ahead and fix that. So let's go ahead to it's in csi.go. So, okay, looks like we have error equals. Let's fix that. And what we can do is just do the same thing, commit our changes. Fix error token issue. So we're just add a new commit so it's easier for Sarah to see what I've changed in this PR instead of create instead of committing to the same commit. And at the end, what we can do is squash the commits into one when we merge so that it's all merged as one feature. Cool. So, oops, I pushed to the wrong remote. It's fine. Push to Sarah's remote. So we're adding the new commit on top of this PR that we've already opened. So we can go back to the PR and see 2 commits have been added. I just added the new one, and now the tests are running again. So speaking of tests, let's actually just go into the test code and check at what exactly we are testing. So we have the CSI driver right here. This is the thing we're actually testing. Specifically, we're testing that when Kubernetes passes a secret, when a user passes a secret in, as we mentioned before, that token will actually get put into the headers and will be sent to the request to Portworx. This is how Portworx authentication works. It basically looks at the authorization header and validates that your token is the correct one. So now that we've kind of gone over the code, let's quickly go over what exactly is happening in our test.sh. So to give the full picture, actually, let's first go to the workflow. So Sarah mentioned the workflow. I'm just going to pull it up so that we can really easily tell. So the build job happens first. My build was passing just fine, so that wasn't the issue. The issue was actually in this test job. So basically, in every Kubernetes version, you noticed it failed. What actually happened was inside of our integration test, this demo/test.sh, we tried to create the PVC, the persistent volume, so that our MySQL pod could use it. But unfortunately, because of the bug I introduced, it wasn't able to do that. So let me go into the test.sh code and just see what exactly we're doing. So here is, let me turn word wrap on. So here's what we're doing in the test.sh. This is a very straightforward demo test. You wouldn't probably actually want to write tests like this in the real world, but for demo purposes, it's a nice little test suite to run. So the first thing that we're going to do is define a token. Now, before you go ahead and copy this long JWT token down, it's not used for anything special. So no need to put in that effort for that.
Development.
Not a good practice to commit this token like this. This is just a test token for running our tests. So next, what we're going to do is we're going to create that Kubernetes secret. So kubectl create secret. This actually creates an encrypted secret stored inside of Kubernetes. And what it'll do is it'll just do auth token equals. So the key for the token is auth-token. And the value will just be this token that we have right here. Next, we're just going to get that token secret and make sure that the token is created successfully. And then what we're going to do is create a storage class. Let's go ahead and look at this storage class to give you an idea. So this is what a storage class looks like in Kubernetes. As I mentioned, it's kind of like a template for creating volumes. And volumes are what hold your data in Kubernetes. So if you're using MySQL, then you would want to use a volume to store your data and make sure that it's persistently stored and not taken away when the pod goes up or down. So here's kind of what we're doing in the storage class. We have a reference to our token secret that we created. And this is just the way that CSI actually allows you to pass token secret, allows you to pass secrets into the requests that we're talking about. So specifically, the provisioner secret name is token secret, and the namespace is just the default namespace. So let's go back to our test.sh. So we got the storage class just fine. And then next, what we're going to do is create that volume. This is what this line does right here. We do kubectl apply on our pvc.yaml. That'll actually go ahead and create this YAML. So this is a persistent volume claim. It basically has 2 GB of storage, and it uses that storage class that we had mentioned before. So it's saying, hey, I would like a persistent volume of size 2 GB, but please use the settings from that storage class that we've already created. So next, what we're going to do is get that PVC and make sure it's bound. So this is actually the line that's been failing. So because this request right here to create a volume is protected by Portworx PX security, what was happening was that when we try to do the PVC creation, it was failing because the token wasn't being passed correctly to the Portworx auth backend. So this line was failing, and you may have noticed this line right here. It was failing specifically. And forget about this line. I wasn't even able to start using the MySQL pod because the PVC wasn't created correctly. So that's kind of what the test is doing. Let's go ahead and look back at the PR and see what's happening there. So it looks like my test is still running. So yeah, here we have, Sarah, do you want to talk a little bit about what's happening right now?
Yeah, so we are, let's see, can we share both screens at the same time? Okay, so we can't. So it's okay. So what you can see here is actually, if you wanted to follow the logs, along the logs, you can click on details and pull up the steps that are being taken. So you can see here where we're setting up kind, similar to what we were showing in that diagram earlier, as well as running our open storage setup. So while these tests run, I'm going back to our conversation here. Within this conversation, you can see these tests are required. Who knows why these are required? Does anybody? If you do, let me know in the chat. And then I'll jump into how I did it and why it's important. All right, so these tests are required because I set our production branch as a protected branch. So you can go into your settings for your repository and you can decide on which branches you see value in blocking merges or causing or enforcing some sort of policies. In this case, our master branches are production branch. So I really don't want anybody merging there unless they had somebody code review, do a code review, as well as all of our tests passing. In this case, we're testing, again, 3 different Kubernetes versions as well as our build job. So at any given point in time, anybody that creates a pull request into our master branch needs to have all of their tests configured correctly and all of their environments configured correctly and any code changes that they made to not break the tests. So if these tests don't pass, we can't merge the pull request. In addition, your GitHub, software engineering overall is more of a team sport. You don't necessarily, sure, you could develop a couple of features together, but you really, if you're working in an environment where there's a lot of collaboration, there's a lot of other team members that can do code reviews for you as well. So going through your code with just a couple other people allows you to really understand what's happening and share that, allows the other person to understand what's happening when you're introducing these new code changes and provide feedback and have a conversation of why these code changes are necessary and why you implemented them in a certain way. So this requires a pull request reviewer. So if I'm adding in new code and it does, for some reason it doesn't make sense, at least somebody else can see it and say, hey, this doesn't make sense. But at any given point in time, if anything that will be a breaking change, your test will be will notify you right off the bat. So let's go, now that we've seen our required, and a couple other things that you could do if you haven't noticed is to disable, or it's automatically by default disabling force pushes and deletions for that master branch. Previously, I worked on a team where somebody decided that it's okay to delete the master branch for some reason, and there was definitely a huge slowdown in our production, in productivity that day. In general, you don't want to delete any branches that are your core production or consistent development branches. Smaller branches, they don't, like the GoLint branch, that's not as required. Awesome. So now that we've covered some of these protected branches, let's go back to the pull request and actually see if the tests have passed. All right, we see a little check mark here. And if we scroll here, sweet, all the checks have passed. But again, the pull request is still blocked until a reviewer. Since Grant created this pull request, I can actually go and review it and provide my approval. So looks good to me. Let's ship it. All right. So now that it's approved by the one reviewer and all the checks have passed, Grant has the power to merge the pull request. So we'll pass it back to Grant to merge that pull request.
Cool. So yeah, Sarah mentioned, go ahead and merge it now. So I'm going to merge it. There we go. I have my feature added to our fork of open storage. So yeah.
Cool. So a couple of the other things we wanted to just touch upon is some of the lessons learned. Overall, GitHub Actions allows you to do a couple different things. And if we can go back to my screen as well, I'll just cover some of the main topics that we touched on. So we took that walk by the river, we had our pipeline, we did our builds and pushes and everything. So some of the things were to note that we triggered this event on pull request. This event, we didn't really need to run the integration test end to end for every push. So it only made sense to run it on a pull request specifically to our production branch, or it might be specifically to your dev branch. We kicked off our build job first and then broke down and broke down our testing job and had 3 jobs run parallel in a matrix build. The great thing about originally what we did was actually have our build job and our test job all in a single job, and it was convoluted. So what happened is every single time I spun up a concurrent parallel matrix build, a build job was happening. So we had 3 build jobs happening all at once, and it just didn't make sense. So splitting up these 2, especially because overall the strategies for one and the other are different, made it much easier to set up our workflow. And last but not least, protected branches. Let me tell you, this saves you so much worry and concern in case somebody does not follow the best practices right off the bat. But that's fine. Mistakes happen, and you can block these mistakes from happening with your branch protection rules. These definitely have to be taken in mind which branch you're using branch protection rules. You don't need to set these up for every single branch. It only really makes sense to block specific things for the specific scenarios that might be detrimental for your production.
So Sarah, I noticed in our workflow that we only test against Kubernetes 117, 118, and 119. Let's say a customer of Portworx wanted to run on Kubernetes 116, and we really wanted to get some test coverage. How might you add that to the matrix job?
Oh, that's a really good question. It's actually super easy to test this in a different Kubernetes version as well, just because we set up that matrix environment variable right off the bat. So if it's a simple change like that, I don't even need to pull the branch down and do it locally. I can just edit the file in the UI as well and edit it here. In general, if I just wanted to add a whole new action, I can actually search for a marketplace for the marketplace here, and we can see that we're using the engineered kind action. And we can see Helm actually created a kind action as well. And there's a couple different things here. There are some documentations on how to configure your environment, your workflows within the setup environment variables and such within the editing itself. So it's really easy. But since I'm only doing a version change, let's just simply do that. Let's test this live. We have not done this before, so let's see how it turns out. All right, so I created a v1.16.15. I believe that's the latest 16. That's the latest minor patch for 1.16. So let's do a pull request and updated KX version. Perfect. So I'm creating this pull request now. So I don't know if you also noticed when creating a pull request, there's some templates that are done here. So you can set these as best practices from the start. But since this is just a demo, let's just skip these and say updated K8 versions to include 1.16. So I'm creating this pull request. And the really nice thing about this, I just made that simple change, that one line change, and now I can test on a completely different Kubernetes version. Hopefully everything will pass, but let's see what happens. And we can go into our actions pipeline to see that in action. Haha. My corny jokes aren't always the bestest, but so we can see that it's actually just spinning up a build job similar to what we had before. And then once this build job passes, it'll spin up the four different Kubernetes versions, jobs for those 4 different Kubernetes versions. And
awesome.
yeah.
Cool. So while this is running, Sarah, we also want to test against different cloud providers, actually. So we want to make sure that our coverage is there for all the different cloud providers. I want to make sure that Portworx works on every cloud out there as part of our business statement. So I was wondering if you could show us any way that we could kind of deploy this to any cloud provider.
That's a really good question, Grant. Yes. So as I touched upon at the beginning of the session, you can click on this new workflow tab within your actions workflows. If you didn't have any actions before, it's super easy. Just it'll pop up right away. But in this case, since I already have some actions and I want to add additional workflows, I can set up an Azure Web App Deploy or an Amazon ECS or GKE. In many cases, these are some of the 3 core cloud providers that you want to deploy to. But it makes sense. I would say some of the lessons learned were great, but what are the next steps for making our workflow a complete end-to-end test? Not only do we test it in the different Kubernetes environments, but then finally deploying this into a production environment, testing it against the different clouds. So this really sets a easy, I would say, workflow setup that gets you started. And if it doesn't necessarily meet the exact standards that you want, you can always customize them. These are really nice because, again, they're developed from the ecosystem, so you can treat them like open source code. They are provided from Amazon themselves, from Azure themselves, from Google Cloud themselves. So they're setting the standards, and we're just allowing the standards to be set across the board and providing these as like template starter workflows. What's really nice actually is the Terraform integration as well. So if you have any infrastructure built out with using Terraform, the Terraform CLI, you can just run your GitHub Actions with Terraform and run your Terraform applies within GitHub Actions and set it up from that. What that really allows you to do is move slowly to that GitOps mentality where things are triggered based on Git events and rather than manual triggers or automated triggers that are not necessarily standardized across the board. So having these capabilities and setting up these workflows make it very easy to just kick off your deployment pipelines as well. And a lot of new features have been coming out about for these, and you can actually check out all the new features that we have. If you haven't done this yet, you can go to the GitHub roadmap, and it is public, and it does it in the most GitHub-y way possible. Oops. It does it in the most GitHub way possible. And if you go check it out, oops, and I have to do my single sign-on. But let's not. There we go. We're very secure now, so we have to do our biometrics as well. Cool. So now that that went through, this is actually public, so you can actually check out the GitHub roadmap and see exactly all the new features are coming out. A lot of our capabilities are called Code to Cloud, so you can actually search for specifically the tags that we have for all of our environments. So you can click on Cloud as a label, you can talk about GitHub Enterprise, and you can search the roadmap. But anyway, I've talked a lot, so I actually wanted to bring it back to Grant. So Grant, how did you get involved in Kubernetes? What made you, what introduced you to it, and how did you get so involved and even contributing to the open source project?
Yeah, totally. So I got involved with Kubernetes through my company. So at Portworx, there were a couple of features. Well, to start, Portworx as a company uses Kubernetes a lot, and we develop a product that works on top of Kubernetes and helps connect different Kubernetes clusters. So we wanted to get involved in the community and contribute back and add a couple of features that we also needed out of Kubernetes. Specifically, when we were adding our Portworx security implementation, we needed to add a couple things into there to actually make security work within Kubernetes with CSI volumes. So specifically for each CSI request, we wanted to be able to pass in token secrets, and as I mentioned in the demo, and that needs to be done through the CSI spec. So that's actually something that we worked with the team with to kind of get that working. So that's kind of how I got involved. Specifically, I helped out with a feature in Kubernetes called Kubernetes snapshotting. So that's basically being able to snapshot and protect your volumes. In case something bad happens, you will have a snapshot of your volume that you can restore from. Let's say like if there's a server outage or a disk failure or something, and you need to restore from a snapshot, then that's the feature that you would use out of Kubernetes. So I helped with helped with some of the testing and some of the implementation for some smaller features. I'm about like 50-50, half working on like Portworx stuff and half working on Kubernetes stuff, but that varies greatly based on Kubernetes releases and Portworx releases, and so that's kind of how that works.
That's a pretty cool role to have, to be able to contribute to both your internal projects as well as open source projects. Do you have examples of what that Kubernetes testing looks like?
Yeah, let me share my screen actually, and I can go over how Kubernetes kind of uses a similar model. So I can share my screen and show you all what that looks like. So I have the Kubernetes test grid right here. So actually, let me go to the Kubernetes CSI org and show you some of this in action. So this is all the technology behind the interaction between Kubernetes CSI and the Portworx CSI driver. So these are all different sidecar containers. If you're familiar with Kubernetes, most of it's written in Go. So let's go ahead and open up one of the sidecars. We can look at the pull requests open. So a whole bunch of pull requests are open now. And they use kind of a similar structure that we talked about in the demo. In fact, a lot of the ideas we talked about in the demo are inspired by how Kubernetes does things. So that's one of the nice things about working in open source, is that you could look at how other projects are doing their development and kind of see what you can kind of adopt as a result. So let's go ahead. This is just let's look at this PR, for example. This is just a README update. Nothing like too intense. It looks like some reviewing happens, but at the bottom, you can actually see they have a very similar structure that we have. So this is where we got the idea from and the inspiration from. They run this sidecar Go code on different versions of Kubernetes. So they make sure that the code that this person sent as a pull request is actually working on all these different Kubernetes environments. They additionally run unit tests. They make sure that they've signed a CLA, so this pull request cannot be merged until there's approval, there is the CLA signed, all through Kubernetes jobs have passed, and then the unit tests have passed. So this is kind of that rigorous type of testing and PR validation that Sarah talked about in the beginning that really is important when developing a high functioning software product. So that's kind of how Kubernetes CSI works from an open source perspective and from like a CI/CD perspective. And now we can go to the test grid. So this is actually where the test results actually are. But I think the pull request.
Can you zoom in?
Yeah, I think the pull request did a better job of showing all the different versions. But here's all the history. This isn't through GitHub Actions. This is through, I forget what they're running on, but it's a similar model that we use as well. So these are all the different tests that they're running. So very thorough testing. And as you can see, some have failed in the past, but most are looking pretty green. So I won't go too in depth there. It's kind of complicated, but yeah. So that's kind of how Kubernetes CSI uses this same model. And just a quick shout out to Kubernetes Slack. If you are interested in contributing to CSI, to Kubernetes, you can go to slack.kubernetes.io and you can join the Kubernetes Slack. You can go and find out how Kubernetes is being developed. You can go join any Slack channel you want. It's all open source. It's all open to the public. There might be some private ones for people that are maintaining certain projects, but everything's pretty open, and you can go and check the kind. For example, you can go and check the kind Slack channel. So I'm actually a member of Kubernetes org and the Kubernetes Slack, and I follow Kubernetes kind as well. So here's the Slack channel for kind. People are asking about how to use it, might have pull requests or issues. So this is kind of how kind is developed through this Slack channel, and also a lot of work behind the scenes, of course, a ton of work behind the scenes to make kind possible. But this is kind of the main spot where people go and ask questions, other than GitHub issues and mailing lists and that kind of stuff. So yeah, similarly with CSI as well, you can check out there. So quick shout out if you're interested in contributing. There's a lot of good videos out there as well. If you just search on YouTube, how to contribute to Kubernetes. And Sarah, I think that you also wanted to show how you might be able to find out issues that you want to work on for Kubernetes.
Yeah, and I know we have like 1 minute left, but I'll just show it really quick on what that will look like. So if you go into the Kubernetes open source project, you can actually search for specific issues to find which ones are good to start working on. And if you're new to open source or just new to Kubernetes, you can look at the different labels that are out there. And if you just search help, there's a couple labels that are really good to leverage. It's the help wanted label and the good first issue label. These labels and these labels are usually associated to issues that can help you get started within the open source community and overall the open source community, and even specifically for the Kubernetes community. But with that, I think we are at the end of our time, and we hope that you have learned a couple different things that you might not have otherwise known. If you have any questions and want us to do any other demos, feel free to comment in the chat, and we'll take all your ideas and we'll talk about them within these DevOps demo days. At the end of the day, we are partnering with our community, are partnering with our not only open source community, but our enterprise customer community as well. And we're helping to build these conversations and help build out our community even stronger. So let us know if you have any questions or if you have any ideas. And thanks, everybody.